Good evening. This was a quietly momentous day in the history of man. More than 200 million miles away, on the surface of the planet Mars, the most sensational biological experiment ever attempted was begun. Samples of the Martian soil, seen in this picture taken last night, were scooped up and deposited in several experiment chambers of the Viking 1 spacecraft this morning. The aim of the experiments, like no other ever before, to look for life on another planet. At last report, the experiments were proceeding as planned, although the Viking controllers say a corollary device designed to analyze the soil in another fashion is not yet working properly. Even though there have been a few problems on this mission, nothing has happened to alter the basic aim of Viking, and that is to search for life on Mars.
Mars, the search for life. Reported by NBC News correspondent Jim Hartz.
The Viking mission to explore the surface of Mars is far and away the most ambitious unmanned program ever undertaken by anyone. It was conceived as an alternative to manned flights, which are enormously expensive and severely constrained. Instead of man, the Viking project depends on the successful performance of two of the most complex and sophisticated robot spacecraft ever built, each designed to do almost everything a man could do except move around and bring back samples. They are, in fact, miniature laboratories capable of identifying most of the known elements in the solar system. There are instruments designed to record Martian earthquakes, to measure its gravitational field, and to determine its precise axis of rotation. Advanced cameras have already seen things in spectrums invisible to the human eye. A weather station has measured the temperature, winds, and barometric pressure. In short, the two machines will study the planet's physical, chemical, and magnetic properties down to the molecular level and transmit volumes of data back to Earth automatically. Well, all of this is commendable scientific research that may someday help us to a better understanding of our planet and lead us to the solution of many of our problems. But laudable as these aims may be, it is reasonable to assume that Congress would not have appropriated the funds for the program if the goals were simple intellectual curiosity and pure research. For Viking is not only the most vicariously adventuresome science project NASA has ever undertaken, it is also the most expensive unmanned program ever proposed. Before it's over, $1 billion will have been spent. For that kind of money, there had to be something else. And the something else, in the case of Viking, is its main mission, the search for life on Mars. This is a subject, of course, that's fascinated people for years. In science fiction, Mars was the first symbolic representation of extraterrestrial life in alien worlds. Well, now the fantasy has been replaced by scientific theory. It's generally agreed that if life arose anywhere else in our solar system and can be easily detected, it will likely be found on Mars, the planet that is in many ways most like our own. And so ancient curiosity, modern science, and advanced technology have joined in the search, and it was quietly begun today. Finding life on another planet is not as easy as it sounds. Scientists first had to agree on what constitutes life and then settle on a means to detect it. Roy Neal explains how we will proceed.
Scientists have said all along that if there is life on Mars, it'll be tiny, microorganisms, bacteria. There are three major experiments on board the Viking to look for life. They're in a small container nestled down inside the spacecraft body. Today, the soil surface sampler provided them with samples so they can go to work. One of the experiments will look for Martian life that might resemble plant life here on Earth. The sample's been placed in a sealed chamber provided with Martian atmosphere to which radioactive carbon-14 has been added. Simulated Martian sunlight bathes the scene. If organisms on Mars work like plants on Earth, they will assimilate the radioactive carbon. And when they're heated, they'll release it so that Viking instruments can detect it and radio the results back to Earth. The gas exchange experiment works on the principle that living organisms eat, breathe, and reproduce. In the process, they affect the atmosphere around them. This sample of Martian soil is soaked in liquid food that the scientists call chicken soup and incubated in an atmosphere of known gases. If there is life, some gases will be extracted from the atmosphere and consumed, while others are exhaled. Analyzers again will look for such changes. The third experiment also will look for signs of breathing. The soil sample placed in a sealed chamber is moistened with liquid food that has been laced with radioactive carbon-14. If creatures eat the food, they should give off radioactive gases that can be detected with Geiger counters. It will take about 12 days to complete the first experiment cycle. The scientists say that means they should have the first meaningful answers about life on Mars 12 days from now. But they say the first test results will not be conclusive. If they do find evidence of life, they want to run another entire test using a sample of Martian soil that's been sterilized by heating to make sure the instruments are giving out correct information. If they do not find evidence of life, they want the sampler to scoop up soil from another spot. Each lab can analyze 3 separate samples, so if at first they don't succeed, they can try and try again. The life expectancy of the experiment's equipment is about 2 months. So sometime between 2 weeks and 2 months from now, we should have the answer to this question of life on Mars. If the Viking was a ship of the sea, James Martin would be its captain. As project manager, he tells the crews, the engineers, what to do, and they in turn command the spacecraft. Mr. Martin, could you describe for us how the Viking got to where it is?
Well, it really started on August 20th of last year when we had a beautiful launch from Cape Kennedy. For the last 11 months, the spacecraft has been cruising about 440 million miles on its way to Mars. It arrived there on June 19th. We put it into orbit. We then started to look for landing sites. The first one we looked at was pretty rough, so we moved on, and on the third try, we found a site that looked good both to radar and to our imaging, and we decided to take her down. And we landed on the 20th of July. It was a very successful landing, and we are very pleased with everything we've seen on Mars. It excites the whole world, I think, and certainly me. And we have now dug samples of soil for our life detection tests, which will be going on over the next 2 or 3 weeks.
The search for life on Mars is being directed from Pasadena, California, home of the Rose Bowl and the Jet Propulsion Laboratory. The latter houses Viking Mission Control. JPL, as it's known here, is in the foothills of the San Gabriel Mountains. And for the duration of the Viking mission, it will be home to the 750 people who planned the Mars exploration and are now carrying it out, sometimes in a language that is as foreign as the world they are looking at.
We go ahead and change to an upper or lower turn on XA while we're still on.
I don't agree with that.
And then go through it, because we don't have that much time, Joe.
I don't agree with that.
Well, we can't get in it until out here, after it yaws on way on over.
Oh, okay.
See, we're going to be out.
We have an uplink.
Uplink blackout during that period of time. That's the only reason we was going that route. I just set the soul time up. We got to retard it 1 second every 4th day.
Okay, we'll check them all.
What did you find in your SOE,
You have a DSN SOE?
What did you find in that in the SOE?
Well, I haven't had a chance to look at it. I'm running AK all night with it, but I'm not running any uplink as far as I can see until way late.
Room number 88.
Yeah, Lowell, yeah, someone over there can get together with the LPAC chief and myself and talk about adjusting the track sim freak for the command file going up the lander at about 1000 today.
TC beta for 43?
Yep. In other words, you'd rather have that clock read in Earth receive time for all events rather than
monitor
spacecraft.
on channel 42.
All right. I think the thing is 43 seconds off, one way or the other.
Yeah, I see that.
Lander event time.
That sounds right. Yeah.
For Sol 0. 1857.
Allow the transponder, as it heats up with the best lock frequency, to walk through the uplink frequency that you're going to have there.
This value, that's different. It's about the same as that value.
No, I can't find it.
One of the things we want to do, for example, is get A1 alpha on the IR to get the ground truth benefit. And it looks like the only first time we can get that is on Rev 11. And man, we got to make decisions like down in here.
Yeah.
But all this IR stuff is, all this IR stuff is going to be tight because it's right up against a decision point. You know, what we really need to do at this point is decide whether we're going to go to 2 or 3.
When you put something in the 0 register or something, then you put another item in the 0 register, does that put the previous 0 register into the first? And so push everything back?
It depends on how you do it. There's two modes. You can replace it or you can roll it.
Roll it back? Okay.
Yeah.
In a few cases, he went in and jockeyed the conductors accordingly. It may be that in the process of doing that, we screwed something up.
It's just what one can say is you took 2 parts of pure hematite and mixed it with 1 part of pure goethite. That's approximate of color, but that's not saying that's precisely what the limonite on that surface is. That's all.
This one, did you see that?
Yes.
And I don't see what kind of an artifact it can be. It has to be real, but whether it's on the surface or in the atmosphere, I don't know.
Getting a knob here.
Okay, you're drawing this little section.
Let's try paying and see what it looks like for a minute. Okay, we're over here. Getting the tilt we wanted. Oops. How's that? Yeah, I will. Okay, when?
I know.
Scientists here at the Jet Propulsion Laboratory in California are, of course, overjoyed at the initial success of the first Viking lander. It made it to the surface without damage. It has already sent back photographs remarkable for their clarity and color. It has sampled the atmosphere and found it to contain carbon dioxide, oxygen, and nitrogen, essential ingredients for life as we know it. And people here are hopeful that the first samples they have taken will show that life exists on Mars or might have sometime in the past. One thing that haunts them is that perhaps there are indeed some simple forms of life on Mars, and they have picked the wrong spot to find them. The site selection was not an easy process. It was, in the end, an interdisciplinary compromise. Biology, geology, chemistry, physics, meteorology, and so on, representatives of 13 different investigating groups in all, could scarcely be expected to agree on one particular site. Spacecraft safety was the essential requirement, important above all. The location had to be smooth enough and sufficiently free of rocks and boulders to ensure an intact landing. Next, the biologists wanted an extremely low spot on the theory that if organisms are going to be found, they would be found at the bottom of what once might have been deep oceans. Also, because of the extremely thin Martian atmosphere, low spots are likely to be the only places where the barometric pressure will be high enough to hold water vapor. Finally, it is assumed that any one of a number of locations would be suitable for most of the rest of the experimenters investigating planet-wide phenomenon. It's in the nature of scientists, especially when they are placed in opposing positions, to argue strenuously for their points of view. And indeed, the Viking program has been marked by periodic spirited debate. But on the whole, most observers think this has been one of the most harmonious undertakings of its size ever carried out. There's even a spirit of jubilation, as seen in the face and words of the chairman of the Viking Science Steering Group, Dr. Gerald Soffen. A great deal of attention, in fact, most of the attention on this mission has been focused on the experiments to find life on Mars. But there is a great deal of other science on board the Viking lander. It's taken a back seat, in a sense. Could you describe what else is there and what you've been able to find so far?
Yeah, I like the word backseat because that's a shame, you know, especially as a project scientist. I understand the public can identify with a living thing because that's what we are, biology. But to the scientist who has looked at Mars, we have a plethora of data, an embarrassment of riches, as Carl said one time.
Mm-hmm.
We've begun to understand, for example, how the surface of Mars is. All this, we use the term fluvial activity. What we really mean when we say that is there's catastrophic floods that have happened on Mars that we just don't understand. We've seen the effect of what look like rivers, hundreds of miles wide, that go for long distances and then suddenly disappear. And this whole concept of how water behaves on a planet like Mars isn't understood.
Mm-hmm.
The atmosphere, of course, is just the richest thing that's happened is we suddenly know what the atmosphere of Mars is. All this conjecture, all these, for years, people looking through telescopes and trying to make some guesses as to what, but now we know, for the first time, we really know what the Mars atmosphere is. And these isotope ratios, as you know, there are isotopes of carbon and of nitrogen and of argon. These isotopes are going to allow us to actually trace back through the history of Mars and tell us something about what the origin was, how the gases first come out, how the secondary envelope was formed. The rocks themselves are...
What do the geologists say about the pictures
They're
of rocks?
just going wild. You know, we thought it'd be great if we found 1 or 2 rocks out there. There's a rock for almost every man, woman, and child in the United States, and such a variety of kinds of rocks.
Yeah.
You know, every person in the audience has ever looked at them has been amazed at how similar they are to our rocks.
Yes.
They look like Earth rocks. They look as though you and I were in the southwestern desert walking around. If we stopped our car and saw that orange-colored pink sky and all those rocks underneath it, I'm sure what we'd do is stop and go out and I at least would run up the side of the hill and try to pick up a few and stuff them in my pockets.
You're going to make a decision now about the second lander. Is there anything that you can tell us about where it's going and what will it mean to have 2 on Mars instead of 1?
It's almost like having, well, it's like having your cake and eating it too. For a scientist to have 1 is great. And as you might guess, scientists, we never always agree. We don't always say we should do this or should do that. But the place where we want to put the second one is the place that we consider scientifically the most interesting place on Mars right now, which is up on the northern boundary. This first spacecraft went to more equatorial sites. What we want to do with the second one is get up into the northern sites. First of all, because it's cold. Now that may sound funny because everybody says, well, Mars is already kind of cold. The reason that it's interesting because it's cold is because all of those organic molecules that form in the atmosphere, they really condense out in the snows or ices of Mars, and our hope is to get not on the ice, but close enough so that if there is organics, we'll be able to pick up the rich materials that are on Mars in those northern latitudes.
The second Viking is now scheduled to land on September 4th, and a committee to select where it will put down meets every day to decide which of 3 places it will land. The decision will be based on photographs and other information sent back from the portion of the first Viking that continues to circle Mars, not the part that landed, but the orbiting space station.
Well, let me show you what I think will happen on that. Now, there's a curve over here that shows the temperatures we calculated for the B1 site. If it was Martian average, it would have, its temperatures would change through the day on the order of about 80 degrees Kelvin. And the problem is that the data we have thus far for the B1 site is right in here. And at this time of day, something's going on. We don't know what it is that allows us to tell that
the elephant hide is different than the green mantle.
You see the difference.
But we can map some difference, but we don't know what's causing it. It could be that it's the nature of the blocks and rocks on the surface.
Which way? Pardon? Which way is it different? Which one has the longer thermal constant?
Well, we don't know at the moment because they're all right here, where in theory, if it was a flat-lying surface, which was just made out of either sand or tombstones or something, if it was all flat-lying, we shouldn't be able to tell the difference. But we can tell the difference. We just don't know what is causing that effect. And if we can take that area and look at it at noon and at dawn and late in the evening, then we'll be able to tell which of these temperature curves it's following. And the more temperature variation we see, that means the more amount of sand and fine-grained material which would represent a safe landing spot.
I think an elephant there would make a big difference.
Hey, you're looking for maximum excursions.
Yeah, we're looking for maximum excursions and the minimum temperatures at night.
That's great for comparative purposes.
For comparison, right.
But I know the trap we fell into on the radar, or the problem we fell into. You know, the radar modeling was set up on the basis that it was a homogeneous area, and we got this kind of thing. And, you know, how good is all this going to be when you have a heterogeneous area and you're trying to figure out how many, you know, you got a bunch of terrain units in there and they're all mixed up differently. Can you handle that?
Got any other sorts of data, Norman? You know,
we got to keep our eyes open.
We only measure...
A key factor in the site selection is the relative abundance of water, thought to be under the Martian surface. It is measured by an infrared sensing device on the orbiting station. It is referred to as an IRTM, infrared telemetry.
Why don't you compare, Barney, latitude with longitude, expectations for water?
Well, there's one other point we must remember. On approach, we have this huge amount of water over here. And if that's typical of this whole area, and there is some suggestion that the western side of the Tharsis region is the wet side, the eastern side is the dry side, then this is the wet end of the map. And in that case, we'd like either this end of B2 or that end of B3. But this is purely conjecture now, and we should wait to see.
Let me ask you a $64 question. Maybe it's for Toby. How much water is a lot? I mean, if you have 25 microns here and 22 there, is that significant? If you have 50 here and 20 there, is that significant?
That's significant. Okay. If you have 100 here and 10 here, that's very significant.
Where do you draw the line?
I hate to get hung up on this whole water issue. What we really want to do is avoid desiccated areas. That's the whole point. It isn't chasing for where you get 25% in one place and 30% in another. I think that'd be a mistake. The thing to do is to make sure that whole latitude band, there isn't some anomaly, some unique desiccated area that we should not be going through. I think anything is acceptable within the kind of numbers he's talking about.
I can't believe the water at various longitudes would influence our thinking at all.
Well, we've had a few surprises.
Well, I'm more interested in you know, how reliable we think the IR is going to be, the IRTM. Because it does have to substitute, in a sense, for radar.
That's right.
And we all went through years of debate as to how good radar is. I think we ought to start the process of how good IRTM is, because when we start getting your data, you know, that's going to be kind of late to start debating.
Well, it's the 5th of August is the supposed delivery time of the improved software that fixes the pointing problem.
It's on schedule.
Coming along.
Jim, I would debate you on the question about water in the following sense. If the question is, we have a variety of sites, but there's one that's clearly looks better for safety than the others, then I don't think there's any question. But if we have several places that look more or less the same in the imaging, that is that there's no unexpected, or at least the hazards look comparable, but one of them clearly seems to be a place where the diurnal water cycle is a greater amplitude.
And the same thermal constant.
And, yeah, everything else being more or less equal.
Sure, then you might pick water, but I can't believe Mars is that homogeneous.
I don't believe that you can predict Mars, what Mars is going to do very well.
You can see this low-level condensate in patches on the ground. There are some patches that are wet and some that are not.
Oh, yeah, but I don't believe we'll find more than 1 or 2 at the most ellipses in the whole latitude that we'll say meets the visual and the IRTM criteria. Let alone water considerations. That's
We want a wet ellipse, too.
I know, but we also want a safe landing site.
You want a hot, wet ellipse.
We're willing to take more risks, but that's not foolish risk. You know, we are willing to go, and we have, as far as I'm concerned, we've committed now to ignore radar, which, you know, is debatable, but certainly it was a factor in our choices on the first landing. And so having made that choice, I still think we are now obligated to try and find the safest site in the northern latitude. Because our whole discussion for years now has been that the northern latitude is where the water is. Barney has confirmed that where he's looked.
You just saying the principles are still effective?
Principles are still the same, and if all things were equal, obviously we would then look for the most water. But from our observations of Mars today, I don't believe everything will be equal.
Man's first biological search for life on another planet is underway tonight. The soil samples that might harbor Martian life are sealed inside the experiment containers aboard the Viking spacecraft more than 200 million miles away on Mars. But the incubation process is a slow one, and the measurements are exacting. And even though it is in our nature to want an immediate answer, that is not to be. We'll have to wait patiently for the results, and we may be disappointed on the first try. In a way, what's happening is symbolic of the long road that led to this night. The search for the truth about Mars has been clouded by fancy and sidetracked by error. The mysterious red planet has prompted more ill-informed and misleading speculation than the rest of the heavens put together. In the early part of this century, for example, it was widely believed that Mars was inhabited by a superior, yet decaying civilization. And many of the myths were fostered by men considered to be eminent scientists. In looking back over this period, we went to one of the oldest observatories in the United States, Mount Wilson, not far from the Viking mission control, and talked with a Viking scientist, Dr. Carl Sagan, one of the best-known young astronomers in the country. It might be well to begin by finding out what we knew about Mars before Viking and before Mariner. What did we learn with old telescopes like this? What did we know before that? And how did opinion fluctuate back and forth over the years?
Well, Mars is the closest planet whose surface we can see. It was a natural focus for ground-based astronomers, visual observers who would draw pictures of what they saw. In 1877, almost exactly a century ago, Mars came into one of its occasional close approaches to the Earth, and people looked at it. And some of them saw what they called canals, straight lines which seemed to crisscross the disk. And an American astronomer named Percival Lowell, in fact, built an observatory dedicated to an exploration of these canals. He thought the canals were really canals, waterways carrying water to the thirsty inhabitants of the equatorial cities from the melting polar caps, and the planet was kind of warm, but not as warm as the Earth. The atmosphere was leaking away to space, and the heroic effort of this race of engineers was maintaining life on the planet. The only problem is that the canals don't exist. They are a kind of optical illusion which occurs when the human hand-eye-brain combination is drawing under difficult seeing conditions. The canals of Mars are surely a sign of intelligence, but the question is which side of the telescope was the intelligence on? And we now know that it was this side of the telescope. Well, what happened after that, that sort of turn of the century opinion, by no means all astronomers held that view, but some did, is that there was increasing skepticism about the reality of the canals. It was found that large amounts of oxygen and water vapor did not exist in the atmosphere. This very telescope was used to measure Martian temperatures, and it was found, as you'd expect because it's further from the sun, to be much colder than the Earth. And so the pendulum swung in the direction of a lifeless Mars. And when the first flyby photographs of Mars gave the appearance of a moon-like surface, cratered, people said, that's it, there's no chance of life on Mars. Now, the pendulum began swinging back again in 1971, when the Mariner 9 spacecraft showed that while Mars had a cratered part, it had another part devastatingly different, with sinuous channels produced by running water and immense volcanoes, one of which is 75,000 feet high. And clearly, it was a dynamic, evolving planet, and so the pendulum started swinging a little back, and I think Viking is part of that pendulum swinging, and the recent findings by Viking, for example, nitrogen in the atmosphere, I think have pushed the pendulum a little back more. It's somewhere in the middle now where I think it should have been all along.
I'm with Dr. John Hall, the director of the Lowell Observatory, and this is the observing platform that Percival Lowell used when he set up this observatory some 80 years ago. Set it up to try to find the proof for his belief that there was life on Mars. Dr. Hall, what did he find about Mars?
Well, he found lines on Mars, which were called canals, and in due course he thought some of those lines were even double. And these lines were of such a nature and appeared so straight that he thought that this was evidence of intelligent life.
And he would sit here and look at Mars and other planets too, but particularly Mars, and draw pictures in which he saw those canals. Is that right?
That is correct. And we have many of them, notebooks full of them. For each opposition from 1894 until 1916, he drew lines on globes corresponding to what he saw. Now all of this is done by photography, but we don't get lines.
The cameras never did succeed in filming the lines on which Lowell's whole theory of intelligent life on Mars was constructed. Percival Lowell, who especially admired this elegant photograph of himself, got into the Mars business when he learned that one of his heroes, the Italian astronomer Giovanni Schiaparelli, was losing his eyesight. Schiaparelli was the one who had discovered the lines on Mars, had called them canali. Lowell decided to carry on Schiaparelli's work, and in a matter of months had an observatory dome prefabricated and shipped to Flagstaff, Arizona. He began observing Mars in 1894 and quickly concluded that the lines he saw were not nature's work. He decided they were vegetation growing beside canals built to distribute the planet's meager water supplies. Lowell built a home on what he called Mars Hill in Flagstaff, installed a garden, had a cow named Venus, which eventually had a calf called Satellite. He had a skilled and pretty secretary, Rexy Louise Howard, but he married a Boston lady, his equal in social position, and took her up in a balloon on their London honeymoon to see the pathways in Hyde Park from the air, so he could compare them with the canals on Mars. He and his observatory produced incredibly detailed and systematic records of Mars and other planets as well. In fact, in 1905, he began looking for a planet X, which was found in 1930 by his observatory just where he predicted it would be. It was called Pluto. His facts about the canals were wrong, but on many other basic Martian information, he was right. And his biographer, William Hoyt, thinks he'd be the first to welcome today's new facts.
If Lowell were alive today, of course, and this is a strange thing, to always say, I think, but he would be in the forefront, I think, of the Viking investigation. He might well have wound up principal investigator on the thing.
That's what Lowell was, an investigator with a restless, inventive mind, and his observatory still reflects that. One of its current activities is under NASA, the Center of Planetary Research. The observatory not only found Pluto, another project launched by Lowell led to discoveries that in turn sparked revolutionary ideas about the expanding universe. It wasn't only life on Mars that fascinated Lowell, it was the broad concept of other worlds than our own. And Lowell's work didn't only inspire science fiction writers. Lowell, in fact, made those other worlds respectable subjects for scientific investigation.
The first science fiction book that we know about was written in the 2nd century A.D. So at least since then, men and women have been writing about and dreaming about the stars and planets. But Mars has always fascinated them more than any place. For a moment, look and listen to some of the things that people have been thinking and fantasizing about Mars for hundreds of years. Some saw on its surface a vast network of canals crisscrossing the planet, obviously the work of intelligent beings. Some decided it was massive engineering works to provide water for irrigation and commerce. Some predicted that with larger telescopes, one would see the cities of Mars. There must be cities. What would the people be like? Cool, unsympathetic intellects, some said, looking cross-faced at the planet Earth with envious eyes. Planning an invasion? Earth people speculated so. This is how a man on Mars would look, according to Monsieur Edmond Perrier of the French Museum of Natural History. This film was made in 1919. Gives an idea of what people were thinking about Mars and Martians 57 years ago. This was sober scientific stuff. France offers a great prize to the first man to establish communication with any planet. Professor Pickering of Harvard suggests the following plan. Professor Robert W. Wood of Johns Hopkins University suggests a huge black spot to attract the attention of Mars. Distance, the effect would be flashes of light. Monsieur Flammarion suggests a plan which would probably prove most effective. These lights could be made to wink simultaneously. And someday, perhaps,
I want to destroy the Earth.
This is how millions of Americans first saw Mars, as Hollywood imagined it. Films made in the 30s. No question in these films that there was life on Mars, and it was evil, menacing life to be combated by Flash Gordon.
Do you see that beam of light?
Yes, very clearly.
Then I made a terrible mistake. From my observations on Earth, I thought it was coming from Mongo. It's not. It's coming from Mars.
Mars?
They deserve no mercy at our hands. We don't expect any mercy.
But really, if one talks about science fiction and Mars, one must talk about the man who, more than any other, created the dream. 64 years ago. 1912, the story Under the Moons of Mars was published. The author listed as Norman Bean. Well, he dropped that pen name when he published his next story. Used his real name, Edgar Rice Burroughs. Writing about Mars before he ever dreamed of Tarzan. Burroughs wrote 10 novels about Mars. He was tremendously impressed with the work of the astronomer Percival Lowell. Lowell had told us that there was life on Mars. Edgar Rice Burroughs told us what it was like. He described tharks and thoats and therns and green people 15 feet tall with 4 arms and 2 legs. He told us they could live 1,000 years. They had no language because they could read minds, had no art, no homes, and no love. They hated to work, disliked loud music and noise. The constant senseless chatter of millions of earthly voices, we were told, would drive them insane. Edgar Rice Burroughs wrote, "On Mars, no man lies. If he cannot speak the truth, he is silent." People took to Burroughs' fictional world, maybe because in ways it sounded a little better than the one they were in. Of all his fantasies about Mars, Burroughs once said, "I have great fun with my imaginings, and I can appreciate in a small way the swell time God must have had in creating the universe." If one is inclined to dismiss all of this as foolishness, the stuff that science fiction writers have been feeding us about Mars all these years, one should remember that what they have given us is a dream. Not accurate, but inspiring. And the young boys and girls who saw the films and read the books and went out and looked up into the sky with a sense of wonder a generation ago are the astronomers and physicists and engineers who now have put Viking on Mars. The contemporary science fiction writer Ray Bradbury says we wouldn't be on Mars tonight if there had never been an Edgar Rice Burroughs.
The Viking mission to Mars has drawn an extraordinary amount of favorable news coverage. It is still being played on page one in many major metropolitan newspapers and featured almost nightly on television newscasts. If the editors are correct in their judgment, it means that the story is stirring wide interest, not only here in the United States, but abroad as well. And it's not hard to see why. The search for life is immeasurably more interesting than looking at barren rocks and craters. And in regard to the search for life, the question arises of the worth of the Viking program if life is not found. Well, from a layman's point of view, that would be a disappointment, of course, and perhaps from a scientific point of view as well. But the main goal of science is truth and understanding, not wishful thinking. If they do not find life on Mars, it will mean that either there is no life there, or they have searched in the wrong place, or they have used the wrong techniques. Even if life is not found, the Viking missions will quite likely add a great deal to our already voluminous knowledge of the origin of our solar system and the evolution of life on Earth. And if the mind is like a muscle, the more it is stretched and flexed, the stronger it becomes. There is, too, a remarkable beauty in the pictures Viking has sent back and in the way that they are transmitted.
Actually, there are about 3 or 4 different ways to get pictures from the surface of Mars back here to the surface of the Earth, but I'll explain the one that we use most often. This starts when the lander takes a photograph with its scan camera in response to a command from its computer. It then stores that picture on its own onboard tape recorders. The next opportunity it has to communicate with the orbiter, when the orbiter goes overhead, it will send the picture to the orbiter, and the orbiter will store that radio version of a picture on its tape recorder. Then a little later on in the orbiter has a chance to relay that picture to Earth using its more powerful transmitter and larger antenna. Now, one of 3 receiving stations here on Earth will then receive that radio signal. It takes about 19 minutes for the signal to get from Mars here to Earth, because Mars is 19 light minutes away from the Earth. One of those 3 stations will then, whichever one gets it, will then record it just for safety's sake, but then immediately pass the radio signal on here to Pasadena. If it's an overseas station, such as the one in Madrid or Australia, then that transmission to here to Pasadena will be by satellite. Here in Pasadena, the large computers that we have here take the radio signal and translate it back again into a pictorial signal. And 2 things happen next, right, about the same time. A light signal is produced, which actually exposes a piece of film, and we make a photograph. And the signal is translated into a television-type signal that we can display here in this studio and can send out so that everybody else can see what we're getting from the surface of Mars.
Maybe the greatest value of all this will be psychological. As the country is celebrating its bicentennial, it seems to be searching for new achievements in which it can take pride. Things that point not backward to a troubled past, but forward toward a brighter future. Less than a month after America's 200th birthday, the eyes and ears and minds of the country's finest scientists are extended to unimagined reaches. In its own right, Viking is a superlative achievement. In answer to the question, is there life on Mars? The answer is yes, and it is us. We'll have more in a moment. Dr. Sagan, you have had a chance to look now at the first preliminary results from the first craft to land on Mars and radio back information, pictures. You're now seeking the answer to the question of whether or not there's life there. A larger question, maybe in cosmic terms. What does all this mean? What does it mean to us here on Earth? What does it mean to us in the short run? What does it mean a long time down the line?
Well, I think its historical significance is immense because we are, or at least our machines are, breaking the shackles that tie us to the Earth. We're putting our toes in the cosmic ocean and seeing that it's kind of warm and benign and interesting. And I think in the long historical perspective, this time will be considered as significant and important as the time between, say, the voyages of Columbus and the voyages of Magellan, that early period when European sailors spread out from Europe and saw what the globe was about, what the significance of the Earth was, what there was on the planet. Well, we are profoundly ignorant of what the other planets are about. And that ignorance carries over to our own planet. It's very difficult to understand your own planet until you've looked at a few others, so you have something to compare against. And that's why I think that there are both enormous excitement and adventure. There's no doubt about that. Everyone resonates to the excitement of seeing the first pictures from Mars. But also there's a practical implication for earthbound sciences like geology, meteorology, biology, that have till now been stuck on one planet. They have been limited in their perspectives. It's no fault of the practitioners, it's the fault of the subject matter. And now we're getting weather reports from Mars to test theories of weather on Earth. Our geological perceptions of the Earth are being challenged by what we see on Mars. And if we're lucky enough to find life on Mars, an open question at this minute.
What will that mean?
Well, it certainly will be a revolution to biology, because all the organisms on the Earth are the same. I mean, I know we kind of look different from begonias or whales or beetles or little microbes, but if you look on the fundamental chemical scale, it turns out that the genetic material of all those organisms is made of precisely the same molecule, DNA. And that DNA works through the same molecules in all those organisms called proteins. And even the code book, which translates nucleic acid information into protein information, is identical. The oak tree could read your genetic code. It has the right code book. So we are all the same on this planet. We have no idea what possibilities exist in biology. We only know one kind. Were we to find another example of life, no matter how primitive, microbes are fine, we would then have an opening of horizons. We would know what's possible in biology. We would also have a good idea about the likelihood of life evolving elsewhere. If there are two planets and they both have life independently originating, that's a keen clue that life is easy to come by. And then I think it would be a short step to the grand conclusion that we live in a populated galaxy, that there is life through the galaxy. And I think the step to intelligent life would then only be a small one. On the other hand, if we do not find life on Mars, we will of course be disappointed, but there are a lot of positive aspects to that. We're in a no-lose situation. First of all, it would illuminate the problem of the origin of life. Two planets kind of like each other, same age, similar conditions, life arises on one and not the other. Why? That will say something about what you have to have for the origin of life. And also I think that case will give us a sense of the preciousness of our little planet. Either way, whether we find life or not, I think the point of the uniqueness of human beings, the uniqueness of all organisms on the Earth, will be driven home powerfully Because the clear lesson of evolution is that nowhere else can there be life like here. There may be intelligences elsewhere. They may be smarter and have better music and all the rest of it. But they cannot be human beings. And I think that kind of perspective, deprovincialization, is a major outcome of this space program.